All right, in this video, we're going to look at alcohols and ethers. To start off, it might be helpful to know what alcohols look like. So you need to identify alcohols before naming them. And the sign that you can look for is the hydroxyl group. So if you've got, let's say, this particular carbon, the structure CH2, CH3, and there's an OH. This is what we call a hydroxyl group. If you have a hydroxyl group, chances are you are looking at an alcohol. This specifically is ethanol. We'll talk about ethanol in a bit. So you've got a carbon that's attached to an oxygen, which is attached to a hydrogen, right? So there's an oxygen-hydrogen bond here. Usually, though, we don't have to draw that bond separately. We just write it as an OH. So it is important for you to know that the carbon is bonded to the oxygen, not to the hydrogen, okay? And an ether is very similar. So if you've got an ether, you've got a bunch of carbons. Let's say I've got 2 on this side, and it is still bonded to an oxygen. So the carbon is still bonded to the oxygen, but that particular oxygen is not bonded to a hydrogen like it is for a hydroxyl or for an alcohol. It is bonded to another carbon. Okay. Now, what's on the left side and what's on the right side don't necessarily have to be the same, like you've drawn here, or like you see here. You've got 2 carbons on the left side and 1 carbon on the right side. Doesn't matter. The fact that there's this one oxygen that's bonded to 2 different carbons means that this is an ether. So I've got an ether here and an alcohol here. Our goal by the end of this video is for you to be able to name these. So name alcohols and name ethers. So before we get into more information, an alcohol can be a primary alcohol, a secondary alcohol, or a tertiary alcohol. And that has to do with what the carbon is attached to. So for example, we already learned that an alcohol has a carbon bonded to an OH group, right? If this is a primary alcohol, then the first carbon, the carbon that the OH is attached to, will be attached to another carbon, okay? And the other 2 will be hydrogens. So because this is there's 1 carbon that this carbon is attached to, this is what we call a primary alcohol. You'll notice that this is written in the textbook as well as a 1 to the degree sign. That means primary alcohol. Similarly, a secondary alcohol will have the same idea. So the carbon that's attached to the hydroxyl group, because it's a secondary alcohol, will be attached to 2 different carbons, right? So it'll be 2 carbons here, instead of the 1 like we saw in the primary. So we've got 2 carbons here, and that's what makes this a secondary alcohol. And these carbons can be in and of itself attached to other carbons as well. I'm just showing you an example here with just CH3, but it could be a C that's then attached to another C, and so on and so forth. Another way of thinking about it is that a primary alcohol would have that carbon attached to 2 hydrogens, and a secondary alcohol will have that carbon attached to 1 hydrogen. So there's a few ways of you remembering this. And lastly, a tertiary alcohol similarly has the carbon that the OH, the hydroxyl group, is attached to, will be attached to 3 different carbons, right? So because this is 3 different carbons, this would be a tertiary alcohol. So we've got primary alcohols, secondary alcohols, and tertiary alcohols. This is just important information for you to be able to distinguish between the types of alcohols. Okay, so having said that, let's look at what our naming practices look like for alcohols. So here's our first example, and our rules that we learned for our previous naming. So for our alkanes and our alkynes and our alkenes, all of that kind of stays the same. So you always still want to identify the longest continuous carbon chain. The one difference here is that you want to give priority to the carbon that the hydroxyl is attached to. So because I see that this OH is attached to this carbon, this is going to be automatically carbon number 1, carbon number 2, carbon number 3. So because I see 3 carbons, I am going to write propane. And I'm going to start off with the alkane naming and make some changes to it. I think it becomes a lot easier for us to do it that way. So I'm going to write propane, and then I'm going to get rid of this E. I don't need the E for when I'm naming alcohols. So propan, and then I want to specify the number that the number of the carbon that the OH is attached to, and then I want to change the ending to OL, so all. So propan 1-ol would be this structure that you see here. Now I want you to think about this. I won't tell you the answer, but maybe we can talk about it in class tomorrow. This particular structure is ethanol. So this is ethanol. I want you to think about why we do not have to specify the number for ethanol, the location of the carbon for this particular structure. So I want you to think about that. So if this is example number 1, I want you to think about example number 2. Let's do a third example. I'm just going to draw it on the screen here. How about if we have 3 carbons, but this time it is, so I'm just going to put an arrow here. This time the hydroxyl group is on carbon number 2. So CH3, CH, and CH3. So in this case, I want to give the lowest possible number to the carbon that the OH is attached to. So I can't make this carbon number 1 because then I can't use that as my longest continuous carbon chain. I want the 3 carbons to be my longest. The lowest possible number that I could give it is the 2. So in this case, this would be propan 2-ol. Okay, so example number 1 was propan 1-ol, example number 2 was ethanol, and example number 3 was propan 2-ol. Hopefully you have an idea as to why the ethanol, we don't have to tell or specify the number for that. Okay, so 1, 2, and 3, let's look at example number 4. So in example number 4, again, I want to give the carbon that the hydroxyl is attached to the lowest possible number. Now, I wouldn't want to give this a 1 because I want my longest continuous carbon chain to be as long as possible, right? So the lowest possible number that I could give it is 2. So I'm going to start here. 1, 2, 3, 4, 5, 6. Okay, so I see that I have hexane, right? Hexane is the thing. I'm going to get rid of the E in my alkane naming. And then I want to include the number for where my hydroxyl is attached to. So the hydroxyl is attached to carbon number 2, so that's why I've got a 2 here. And the ending OL just tells me that it's an alcohol. Okay, so I've got my parent name kind of done. Now you'll notice that there is a carbon here that I did not account for. This is a side group. So I've got this group here, and because there's just the 1 dot there, that's a methyl group, and it's at carbon number 5. So it's going to be 5-methyl hexane 2-ol. So that would be example number 4. And example number 5 here is, we'll see, let's try and number these. So I've got a few different possibilities. So I could go 1, 2, 3, 4, or I could go 1, 2, 3, 4. Okay, going from left to right makes my hydroxyls on carbons 2, 3, and 4. Don't really like that because if I go from right to left, it's much better. I've got 1, 2, and 3. My hydroxyls are on the carbons 4. So I'm going to keep that as right to left naming. And it's the same rules that we've been doing previously, right? So I've got 4 carbons here, so that would be butan. Now I've got 3 different hydroxyl groups, so I'm going to specify all of those numbers. So butan 1, 2, 3. And because there's 3 alcohols or 3 hydroxyl groups, I'm going to write triol. So this would be butane 1,2,3-triol. Okay, so this was example number 5. Let's do example number 6. So in example 6 here, we've got a slightly different molecule. We've got a cyclic alkane with the alcohol attached to it. So it's not too complicated if you think about the rules, right? So we've got this hydroxyl group attached to this carbon. So I'm going to call this carbon number 1, 2, 3, 4, 5, 6. Okay, that's one way of naming it. My other way of naming it is, let me see if I can find a different color. 1, 2, 3, 4, 5, 6. So one of these is better than the other, but we'll talk about that after we name our parent. So our parent name would be cyclohexane, right? So our alkane is cyclohexane because there's 3 carbons in a cyclic structure here. And then I'm going to get rid of the E here, and I want to write hexanol, which is hexanol. Now, again, I want you to think about, why aren't we specifying the number for the alcohol here? We don't need to, in this case, for a cyclic, we don't need to for this particular example because it's a cyclic compound. And wherever the hydroxyl is attached, we want to give that priority. Okay, so having done that section, let's talk about the numbering of these so that we can account for the side groups. So my side groups are here. So I've got 2 methyl groups attached to this particular carbon here, right? And when I specify these, I can either write 2,2-dimethyl, or I'll have to write 6,6-dimethyl. But I want to give the lowest possible numbers to these methyls, right? So I'm going to get rid of this numbering because that means that I would have a larger number, and I'm going to number it as 2,2-dimethyl. I'm running out of space here. I'm going to write that again. But the idea here is that you want to give the lowest possible numbers to any other side groups. So the rules that we learned earlier don't really go anywhere. We are using that. We're just building upon these as we go through each of the different functional groups. So that would be 2,2-dimethyl cyclohexanol. So because this is a cyclic compound and there's only one hydroxyl group, the carbon that hydroxyl group is attached to has got to be carbon number 1. Okay, so I'm giving that priority. Because that's the case, I don't have to write down the number. It's only if I have, let's say I had more than one hydroxyl group, that I would have to specify the number for a cyclic compound. Okay, so for the other ones that we saw, we have to specify number when there's more than one different possibility, right? So here, I had a few different hydroxyls, so I had to specify. In the other examples, if I just said hexanol here, there's a few different possibilities that you could have the hydroxyl on. In this particular example, because it's a cyclohexane, and there's only one of those alcohols, whichever one that I attach the OH to has got to be 1. It's always going to be 1, which is why I don't have to specify the number there. Okay, now we're going to take a look at a few ethers. So as I mentioned earlier, we've got, for an ether, we've got an oxygen that's bonded to 2 different carbons, right? And on one side, we're always going to have a shorter chain, and on the other side, we're going to have a longer chain. So here we've got a methyl group, and here we've got an ethyl group, right? And we want to start off with our naming in our shorter section. So here I've got 1 carbon, so that's going to be meth. And I only want to use my prefix. I don't need to go into my full alkane naming quite yet, not for the shorter chain. So it would be meth. And then what makes this an ether is we have to write oxy. So it would be methoxy. And then our longer chain, which is ethane. So methoxyethane would be this particular compound here. We do have to specify numbers, but not for this example. So I'll come back to this after we do a few other examples, and we'll talk about why we don't have any numbers associated with this particular example. So let's take a look at this case here. So here's another way to sort of name this. So I'm going to find or identify my longest section. So the O is attached to one carbon here, and it's attached to 1, 2, 3, 4, 5, 6 carbons on this side. So obviously I've got hexane here, right? And I want to number this hexane so that the carbon that the O is attached to has the lowest possible number, right? So I'm going to start here. So this is 1, 2, 3, 4, 5, 6. Now, I know that some people get confused by this, but this in and of itself is not a carbon, right? Because we have this O here, this line is just to show that this carbon is bonded to this oxygen. So we don't consider that to be a carbon at all. So this is just to show that the oxygen is bonded to this carbon. And then I've got this the small group here, right? So this is a methyl group. So this would be methoxyhexane. Now, the numbering comes in at this stage. After you've named the short section and the long section, and I've put oxy in the middle of it, I want to specify which carbon on the longer chain that this oxygen is attached to. So this oxygen is attached to carbon number 2 on the longer chain. So this would be 2-methoxyhexane. So the numbering comes all the way at the front, but it is connected to the longer chain. So you want to make sure that you get that correct. Okay, this next example, if you want to try this by yourself, and then maybe we can take it up. So I'm going to try and number this longer chain. So I've got 1, 2, 3, 4, 5 here, and then 1, 2, 3 here. So I wanted to number the longer chain first. So this is 1, 2, 3, 4, 5, and that would be pentane. And this is an oxygen bonded to 2 different carbons. So that would be, I know that this is an ether, so I've got to put the oxy there. And then I've got 1, 2, 3, a 3 carbon chain here. So that would be prop. So prop-oxy-pentane. And again, I have to specify which carbon the oxygen is attached to on the longer chain. So the longer chain is the pentane chain. It is attached to carbon number 2. So this would be 2-prop-oxy-pentane. Okay, so that is our lesson on alcohols and ethers. Tomorrow in class, we'll look at a few more practice questions as well as drawing these structures as well.